Guys, as soon as the projector powers up, we'll continue talking about arrays. So what we've said is that an array is a contiguous series of values. So normally a variable holds a value. X is equal to 1, 2, or 3. Or you can have a more complex data type, a class that can hold, a cluster of values. But an array can hold a series of values, and it can hold a series of objects as well. So we're going to play with some of those ideas today. I wish the PowerPoint would remember where I was. So if we need to get the length of the array, there's the .length property. If colors is the name of the array, you can use colors.length to figure it out. Why do you need that? So that you can count, so you can iterate through the array. Although if you use the other for loop syntax, the for each syntax, then that is calculated automatically. You just do for int I colon, or excuse me, since this is strings, we'd have to do for string and then give a temporary variable name like s inside colors. Like that, and then we could print out s, just like that. The only problem with a for each like that is that you don't have access to the original array. You're getting a copy of the value, which usually doesn't matter, but if you're trying to change the values as you go through it, it matters a lot. So you can't use for each for everything, but the syntax sure is nice for the things that you can use it for. So let's play with making an array, filling it with, just simple integers, but then we're going to make an array that has a class in it, that has objects in it. So I made a new project. Even a string is a class, so pretty much we already have been creating objects and putting them in an array. But let's do our more complex type. So a simple array. Int nums is equal to new int 10. Yay, we have 10 numbers. Let's store 10 contiguous values in it. Since we're changing the values of them, we can't use a for each loop, so we'll use a for loop. For int I is equal to 0, I is less, we're not going to do 10, that's not too cool, so instead we're going to do nums.length. And then we can say nums at index I is equal to I, whatever. That'll fill it up with the values 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. Let's go ahead and print it out. System.out.println arrays.toString parentheses nums. Scripting languages like Python tend to let you just print things without calling a helper class, arrays.toString, but it's okay. We're cool. We can remember that we have our helper class arrays that'll do a lot of different things. All right, 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. It'd be niftier if those were random numbers, randomly generated ints. So, let's do that. We know we're going to need the random class. I don't remember where it is, so I'm going to do Java random class in Google. It's in java.lang.object, java.util.random. Okay, we can do that. So under our import java.util.arrays, did I add that? Did I click on the error and add it automatically? I don't remember doing that. Did I just do that out of habit? That was not there. And then, yeah, okay. I typed arrays.toString, and just purely out of habit, I came over here and I clicked the red arrow. That adds the import. Remember, if you're going to start using the cheaty little NetBeans, never choose create class. Never, never, never. But if it says add import, you're usually pretty safe. So we want one for the util class, the random class, excuse me, java.util.random. Let's create a random object. I'm going to do that above our array. So random rnd equals new random. And here, where we have our for loop assigning the values to the nums array, so I just added that. Don't want to go too fast. I just added that. Now I'm going to come down here, and inside of our for loop, nums at position I is equal to rnd dot next int with an upwards bound of 100. And let's go read the documentation on next int to find out if that means 0 to 99 or if it means 0 to 100. So I right click on the phrase next int, do show javadoc. Next int is a bound. It goes from 0 inclusive to the specified value exclusive. So it'll generate the numbers from 0 to 99 there. Good enough. If we were going to add some comments to be cool, this would be declare our array, and this would be fill our array with random numbers. Why random numbers? Because they're more fun. You know, we don't want to see the same data every time we run it. It's very possible we're going to see the same data anyways. I forget whether it's C++ or whether it's Java that auto seeds its random class. I believe Java does. I don't believe we're going to see the same ones every time. Okay, so when I ran it, I see 37, 13, 26, and so on. I run it again. Okay, I did get different numbers. Cool. All right. Let's do the usual. Let's sum those numbers up with a for loop or a for each loop. But it'd be more interesting to search that array for a specific value. And right now the values are not likely to be in there, right? 9, we have 10 numbers, but we have a range of 100, and there's only going to be a 10% of every number in here. Let's lower this down to 10. A random number between 0 and 9. It's far more likely that we're going to find our number there. Now let's search the array. We'll probably wind up making this a function. Search the array for a 0. It's possible that there's going to be zeros in it, right? Because it's between 0 and 9. The way you search is you start at the beginning. You check if it equals. If it does, great. Take note of that somehow. Either record the index value or print the value that you're looking for or whatever. And then increment your counter. So you can keep checking. So let's declare an index I found at, but we're going to set it equal to -1. And if we never find the value, then I found at is still going to be -1 at the end of the loop. Now we need our usual for loop. And I would like to use a for each, but we have to use a for loop because we need our index value. For int I is equal to 0, I is less than the length of the array, nums.length, I plus plus. And we're going to check the value. Well, we don't have a variable that we're looking for. So let's declare another variable called target. Int target equals, let's not do 0, that looks suspicious. Let's do 9, value to find. So if nums at that index value, nums at index I, is equal to a target. Yay, we have found it. We could print a message saying that we found it, but most importantly, we need to set our positional counter equal to that index. Now, do we want to break the loop at that point? It depends. Do we want to find the first occurrence or the last occurrence? If we want to find the first occurrence of it, we would break at this point. We found the first one in the list. And so I say let's do that. Now, if we get to this point, we are done searching. If I found at still equals -1, then it was not found. So let's check. I'm going to condense my comment a little bit so it takes up only 2 lines rather than 3. All right, so if I found that is less than 0, why not just -1? Well, whatever. Then print out target not found. Why don't we even print the target? So let's use a formatted print statement, printf. So %d not found in nums. And %d was our target value, but we need a slash in there. Else, let's print out what position we found it at. System.out.print f %d found at index %d /n. The first placeholder being the target value, the second one being the index where we actually found it. Wish I could get all this on one screen at one time. I think I'm going to do the nasty thing of moving my braces up to the line above. Okay, it's all on one line now, isn't it? So I run it. There's our array. The random numbers were 9, 0, 1, 4, 8, whatever. It found it on the very first position. I want to run it again. This time the 9 was here at index value 3, starting at 0, 0, 1, 2, 3. I wonder how many times we have to run it before we get an instance where it's not found. There we go. There are no 9s in the array, and so it didn't find it. You may be familiar with the idea of something returning -1 if not found. The string search function. If it doesn't find it, it returns a -1. Same idea. You just have to have some kind of indicator that indicates whether it's found or not.
What's on line 47?
Nothing. Oh, sorry. Something important. The placeholder values that we're printing in were on the last line. So that's in the PowerPoint as searching an array. Searching an array. What you do is they show it with a while loop. While loops are cool. You wouldn't have to use a break if you were using a while loop. While I is less than number of filled elements, if the list at position I equals it, do something and stop the loop. Else increment I. We could have written it like that if we wanted to. I'm just awfully fond of for loops. It would look like this. We need a counter. And counter is equal to 0. Found at, or I found at, is equal to -1 because we haven't found it yet. And then while counter is less than the length of the array, nums.length. If nums.length is equal to our target, excuse me, not the length. If num's index position counter is equal to our target, yay, we found it. So set I found at equal to our counter. But that's not going to break it. So let's put an and in our clause here. So while counter is less than nums.length and I found at is less than 0. I cannot type today. Found at less than 0. And then we need to increment the counter every time. Same idea. Those lines of code versus our for loop up above, they both do exactly the same thing. I say that, but I should run it to test it right.
Why'd you have to make that an and statement? Why'd you have to do I found out is less than 0?
Because I wanted it to stop the moment it found it.
Oh, okay, it makes sense.
Right, right. So that's why I tacked that code on here, so that it would stop as soon as it found it. If we didn't have that on there, it'd find the last position of it, which might be okay, you know. But that serves the purpose of doing the break there when we found it. And we could have just encoded a break there as well. So if you like the clean logic of a while, that's cool. I say it's clean, but it requires a more complex condition there, but it didn't require a break. If you like for loops like I do it like that. It's 6 of one, half a dozen of the other. Okay, so let's find the maximum value in the array. To find the maximum value in the array, we need to start comparing all the values against all the other ones. So what I would do is I would initialize a value with the first value in the array, and then I would check them sequentially to see if any of the others are larger than that value. And I think we demoed this at the end of last week.
Yeah.
So int max found is equal to whatever, the first value in the array. Some people do something a little bit different. They set max found equal to the lowest possible number, which would be something like this. Integer with a capital I dot min value. That's the minimum possible value. Why would you do that? Well, if you had an array size of 0, you'd want to know that there weren't any data in it at all. But I don't want to do that. I'm just going to say nums at the first position.
How would that work without having an array first?
Well, here, okay, let's do it like that then.
I just didn't.
Very good. Let's stick with this rather than change. Okay, so now let's write our little while loop, or our for loop, for int I is equal to 0, I is less than nums.length, I plus plus. If nums at that specific position is less than our max found, then max found equals that value. And here we could have actually used a for each loop. That would have made the syntax nicer. Almost tempted to go back and rewrite it as a for each loop. That would look like this. Max found is equal to integer dot min value. And then for every int value found in the nums array, if the value is less than the maximum we've already found, then max found becomes that value. So since integer.min value is -2 billion, if we get through this loop and integer.min value is still -2 billion, it means that there was no valid data in the array. Pretty much. Could be that the array was set to the minimum value of an integer. So you could do this. If max found is still equal to integer.min value, then print no values in array. max found.
Min value is negative 2 billion or something.
Right. Integer.minimum value shows you the smallest value that can be stored in an integer, negative 2.1 billion or whatever, while integer.max value shows the largest. So no max found, empty array, else print the max found that we actually did. Else system.out.println max found equals plus max found. Sometimes you care about the index position, not only the maximum value you find, but the index position. And we didn't really track that. And I want to kind of ignore now the idea of empty lists, okay? We're pretty sure that these aren't empty lists. We're defining the arrays ourselves. So we're going to rejigger this a little bit. We want to write a little bit more. Find the index of the max value in the array. Assume no zero length arrays. Alrighty. I've already forgotten what all of our variables are called.
Max found. We could just restart here.
So we need some new variables. Int max index is equal to 0, and int max value, I've already used that one, is equal to the first value of the array. Now I can't use a for each loop. Why? Because I care very much about the index value. So I'm going to use a for loop. For int I is equal to 0, I is less than, you get tired of typing this, nums.length, I plus plus, if the value at that position is greater than our max value. You could flip that logic. If max value is, yeah, let's do that. If max value is less than the value of nums at index I, then max value equals nums at index I. Howsoever, we also want to keep track of the index. So I'm going to add a parentheses here, a brace, so that I can do max index equals I. Why do you care about that? Because if we have parallel arrays, we may just need to know the index of this value so that we could print the associated index, so we can print the associated value in a different item. And we'll talk about parallel arrays in a minute. Alrighty, let's print this stuff out. We have two bits of information here. System.out.print f max value equals %d at position %d / n, comma, max value, comma, max index. No facts, max found, empty array. Apparently I have an error there. But this seemed to work, right? Max value equals 8 at position 2. I'm going to have to go back and see what I did wrong there. The max value was 8. That looks right. There was another 8 found there, but we recorded the first position. That's probably okay. All right, I'm going to scroll up here and see what I did wrong here. Where was that code? If max found is still equal to integer, no max found. Is this, I worded this wrong. What did I do wrong here?
It should either be max found is greater.
It should be value greater than max found, or reverse the order of them. I like this syntax. If max found is less than the value, max found is equal to the value, right? I like that better. So in our first one where we use min value, I had that logic wrong. So fix that line. If max found less value, then max found equals value. All right, so it works. And I don't particularly care if you ever use this min value thing. I find it easier just to set it equal to the first value in the array. But that does assume that you actually have valid data in the array. Or a list, an array of greater than length 0.
Anytime we run, I set my array link to the max value of the integer, but it's very low.
All right, so the next thing we're going to talk about is the idea of parallel arrays. Parallel arrays are when you have multiple arrays of the same length. Multiple arrays of the same length where the data values are linked by their indexes.
Your meeting's at 3.
It's actually a little after 3. We can go for about 15 more minutes. Thanks. Okay, so for example, you might have some students, and their names are Bob, Carol, and David. And then their GPAs. Double GPAs equals 3.9, 4.1, 3.8. I put a quote there, but these are numeric values. We don't need any quotes there. All right, and lastly, their favorite food. Fave food is equal to Bob likes pizza, Carol likes hummus, David is really weird, he likes dirt. Here we go. It's saying I have a syntax error in that declaration. I'm not spotting it yet. Oh, that's because I made it double, but these are strings. Okay. So, does this meet the criteria? Yes. Parallel arrays, multiple arrays of the same length. Each one of them is 3 items long. The data values are linked by their index values. So Bob has an index of 3.9 and likes pizza. Carol has a GPA 4.1 and likes hummus. David has a GPA 3.8 and eats nice, nutritious dirt. So let's print out a list. Since these are all linked by their index value, we can print out a table that has all 3 things in them. So for int I is equal to 0, I can't use a for each loop because I need this index value, because I'm going to be accessing 3 arrays, not just one. I is less than the length. Let's just pick one of the lengths. We're going to assume that they're all the same. So students.length, I++. Now we're going to use a formatted print statement. System.out.println, no, printf. And we want them to be nicely lined up in a table. Let's give them each 10 spaces. %10s, %10s. No, the second one's going to be a GPA. So %10s, %10f for floating point, %10s. Because we have 2 strings and a floating point between them. /n, end quote, comma. Now we want the student's name at that position, index I. We want their GPAs at index I. And we want their fave food at index I. And so we print out the table and it shows Bob GPA, favorite food there. Carol, that. Let's print out a nice little header. Obviously, we don't need GPA out to 6 decimal places. We could fix that a little bit. We just make it %10.2f. And maybe we want all the words left justified rather than right. So % minus 10s, % minus 10.2f, % minus 10s. Now when we run it, everything will be left justified. And let's print some headers for our table, just to pretty print. System.out.printf. I don't know, how about just 10 dashes? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, followed by a space. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, followed by a space. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Those are going to be the dashes. That doesn't need to be a printf, does it? If it is a printf, we need to tack on our %n at the end. Is this really important at a lesson? No. But I would like for you to try to make your arrays look kind of pretty, if you can, when you print them out. And let's actually print out some headers. System.out.printf. % minus 10s. Why s? Because it's going to be a word. We want it left justified just like the other data. % minus 10s. That's also going to be a word. And then % minus 10s. And then a /n. And our words are going to be name on the next line, end quote, comma, GPA, end quote, comma, fave food. See if we can get all this on the screen at one time. I hope it works. Let me make sure it works first. All right, there we go. A better looking table. Name, GPA, fave food. Bob, Carol, David. If you can, make your arrays look nice. So we have parallel arrays. You can use parallel arrays to do data entry, like the day of the week and the temperature of that day, or the month and the rainfall. So let's do day of week, and then this will be the last thing that we cover today. So we need an array that represents day of weeks. I'm just going to call it DOW, day of week. And let's go ahead and fill it in. Monday, Tuesday, Wednesday, we live in a strange universe where there's only 4 days of the week. Thursday. And then we want to find out how many sales we made on each of those days. So we're going to need another array of the same length. Double sales is equal to new double of the same length, DOW.length. So that way, you know, if we later on change this so that we fill in Friday, Saturday, and Sunday, then the sales array would be of the same length. So let's make a note of what we're doing here. Parallel array of days of week and sales. Now let's ask them for the sales at that time, at that day. We're going to need a data entry loop. This ought to be old hat by now. For int I is equal to 0, I is less than day of week or sales dot length, whichever, like day of week dot length I plus plus. let's print out a nice little message. System.out.print line, what were the sales on, end quote, plus day of week at index value I. And plus a question mark, just to make it look more like a question, huh? Now we need to read that in. Did I declare scanner? No. All right. Go up a few lines. Scanner SC is equal to new scanner system.in. I'm going to add an import for that. It's safe to click the top add import function. It's not safe to do any of the creates. All righty. I really wish that was up at the top of the code. I will move that up to the random class before we're, underneath the random class before we're done. Okay. So, what were the sales for that week? We've asked them that. How about, I don't know. Needs to be a double. So double D is equal to sc.next double. That's the sales for that day. And then sales at index position I is equal to D. And now we can print them out. How about another loop? For int I is equal to 0. We're printing out parallel arrays, so we do need the index value. I is less than dow.length. I plus plus. Then system.out.printf. The day of the week is only going to be 3 letters long, so %3s. And then percent, I don't know. How many sales could we have? Let's just do 10.2f again. But let's put a $ in front of it to be awesome. So $% %10.2f. Do we want to left justify them? Yeah, why not? So percent minus % minus 10.2f. There's our nice formatting string. And followed by a /n. And what are we going to fill them in with? Day of week, subscript I, comma, sales, subscript I. Yeah, we ought to put a header up there. So, system.out.printf, I'm putting this above it. %3s, % minus 10s, just to make it look exactly like it below, \n. And our header fields are day, in a side of string, so quote day, end quote, comma, and then followed by sales. And if we want to come back and print some nice little dashes underneath it, that'd be great too. All right, this is more than fits on one screen. I'm going to scroll back up to the top. You can pause the recording as you need to. Here's our declaration of the two arrays. Here's our scanner declaration, which we should have done up at the top. Make sure you have an import statement for scanner. Here's our for loop that reads the input in. And then here's our for loop that prints that stuff out. And it's actually asking me for data entry. So what were the sales on Monday? They were 100. Tuesday, they were 200. Wednesday, they were 0. Bummer. Thursday, there were 50. And there's our sales. Monday, Tuesday, Wednesday, Thursday. Could we make that look a little bit better? Yeah, probably. Maybe right justifying it would have looked more awesome. In which case, we could put a plus rather than a minus on each side. So I'm going to come over here and put a plus there. So it says percent plus 10.2f and plus percent plus 10s, just to see if it looks better. Then I run it. Sales on Monday were 10. Sales on Tuesday were 200. Sales on Wednesday were 3,000. Sales on Thursday were 1. Ew, and it blew up. Okay, I'm going to go and remove the pluses rather than take any time to actually figure out what happened. I'm going to make them minus again. All right, so from here, you could calculate the average sale, right? You just sum up all the sales divided by the length of the sales array. You also know how to calculate the minimum and the maximum. So, but if we want the minimum, we don't only want the value, right? Well, maybe we do. I could see one reason to only get the minimum value. I mean the value rather than the index value, because do you remember when we were calculating our numbers and we were only finding the first one that matched 9 rather than all of them that matched 9? Let's work on something like that. Two ways we can handle it. I've already shown you how to get the index number. So for int I is equal to 0, I is less than sales.length, I plus plus. We're going to need some values to hold our index value. So int max underscore index is equal to 0, and int max underscore value, or max underscore sale, is equal to this first position, sales subscript 0. But it's a double. So double max underscore sale is equal to sales at 0. Now we just need our traditional little loop. If max underscore sale is less than our current value, sales at position I, then we want to record the index value, perhaps. Max index is equal to I, and max sale is equal to sales at that specific value. Or switch those statements if you'd like them to be in the opposite order. So now we could print out what day our max was. System.out.print the day with the max sale of system.out.printf. Let's do a $, %.2f was %s, comma, and then our max underscore sale, and then our day of week at that max index. Like that. So we iterate through the loop, we find the max value, or excuse me, the max sale, we find the index at which that was there. So I'm going to run it and test it. There is something that I consider a slight problem, but I'm not going to count off for y'all if your program exhibits the same thing, which is what happens if you have 2 days with the same max. So I run it, sales on Monday were 10, sales on Tuesday were 20, sales on Wednesday were 1, sales on Thursday were 20. And it will tell us that the day of the max sale of $20 was Tuesday. Well, that's true, but it also was on Thursday. So what we could do is we could iterate through the loop again, finding all the values that match our max sale. So I'm going to comment this stuff out a little bit. Maybe just change it a little bit. System. Let's print out the max sale and then print out a list of days. System.out.print line or printf max sale was %.2f on and then /n. So we're going to print out the max sale, but now we need a for loop to match all of those times. So for int I is equal to 0, get tired of typing this, I is less than sales.length, I plus plus. Now if the sale at that day, sale subscript I, equals our max day, so max sale, then print out that day. System.out.println day of week at that position, that index, plus followed by a space. Alright, so what were the sales on Monday? They were 10. Sales on Tuesday were 20. Sales on Wednesday were 0. And the sales on Thursday were 20. And it said the max sales was, well, I obviously botched that. It's not supposed to say $.2f. I forgot a % sign. On Tuesday with Thursday. Could I make that look better? Yeah, I shouldn't be using print lines. I should just be using prints. You know, I actually need to put a % sign here where it says $.2f. It should be $%.2f. I need one final print to go to the next line after my list of days. And now it will be behaved appropriately. Sales on Monday were 100, sales on Tuesday were 250, sales on Wednesday were 3, sales on Thursday were 250, and so the max sale was $250 on Tuesday and Thursday. And that's correct. Okay, so we're going to modify, let's come up with a new homework assignment based on this similar concept. Write a program that will track the highest recorded temperature over 12 months. Prompt the user like this. What was the temperature in December 2017? So we better ask the user first what year it is. What year is it? Question mark. And they type in 2017. What is the temperature in December 2017? You know, or actually we started January, right? January. They type in, 12 degrees. What was the maximum temperature? And so on. What was the max temperature in February 2017? 30 degrees. After the user enters all that, guess what? Print out the average. And the months of the highest temperature.
And what did you say to do to solve when there's two that have the same temperature?
I'd like for you to print all the months, but if you only print the first one, good enough. But I'd like for you to print all the months that match. And the way you do that is with a loop like this, where you get the maximum value and then you iterate through the loop a second time, finding each month that matches. Does that make sense?
Okay.
Okay. All right. So hopefully that's clear. I will rewrite this a little bit, create a Dropbox for it. Let's make a Dropbox for our daily. Dropbox D is there, and I'll make the homework box later.